Module 7, Investigation 8, the tangent function. Consider the graph below, which shows the first quadrant of the coordinate plane. The bottom left corner is 0, 0. The point A is 1, 0, and the point J is 0, 1. Assume the distance between consecutive points on the curve represents 1/9 of a quarter circle. The radius of the circle is 1 unit. I just want to count these and make sure there's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So each of these arc length distances is 1/9 of the quarter circle. Consider the angle that is formed by the initial ray passing through the origin at point A and the terminal ray passing through origin and point B. So we're looking at the angle formed by this initial ray and this terminal ray. What is the measure of this angle in radians? Well, radians tells us how much of what percentage of the circle's circumference the arc subtends in radians. And what we have is we have 1/9 of a fourth of the entire circumference, which is 2 pi. So that's 2 pi over 36, which is pi over 18 radians. The way the book did it was they said we have pi over 2 radians in a quarter, and if we take 1/9 of that, we get pi over 18. What is the ordered pair xy describing the location of point B? Well, since we're on the unit circle, we can say that x is cosine theta and y is sine theta. And we know what theta is in this case, pi over 18, so the point is cosine of pi over 18, comma, sine of pi over 18, and this is the approximate coordinates of that point. 0.9848, that seems about right. We're almost a full radius length, and then 0.1736 of a radius length vertically. What is the slope of the terminal ray passing through the origin at point B? So the slope of this line, so how do we find slope of this line? Let's see. There's lots of ways that we could find slope here. What do you know about slope? One thing you may know is slope is rise over run, so that just means the vertical change divided by the horizontal change, which would just be y divided by x, or sine of theta divided by cosine of theta. Notice that if you use the slope formula, m equal y2 minus y1 over x2 minus x1, you get the same thing, because the second point xy is b, and that's cosine of theta comma sine theta, so the y coordinate is sine theta, and the origin point is 0. But regardless, we get, for that line, sine of pi over 18 divided by cosine of pi over 18. Which is about 0.1763. Consider the angle that is formed by the initial ray passing through the origin at point A and the terminal ray passing through the origin at point C. Or, yeah, let's go take a look at that. Now we're interested in this angle here. What is the measure of this angle in radians? So what is the measure of this angle in radians? Well, now we have 2/9 of the circumference let me just rephrase this again. So we have the angle measure in radians is the percentage of the circumference that we cut out. And we know that there are 2 pi radians all the way around, and we are looking at 1/4 of that circumference and 2/9 of that. So that is 2/9 times pi over 2, which is pi over 9 radians. I also could have looked at above. We had pi over 18 was one of those ninths, so I know that 2 of them would be 2 pi over 18 or pi over 9. What is the ordered pair xy describing the location of point C? Well, it would just be cosine of the angle and sine of the angle. In this case, cosine of pi over 9, sine of pi over 9. Which is approximately 0.9397 0.3420. What is the slope of the terminal ray that passes through the origin in point C? So we could look at the change in y over the change in x, which is just y over x, or the sine of our angle divided by the cosine of our angle. And that would be the slope of this line. And that's about 0.3640. Should be a little bit steeper than the last slope that we found, which was 0.1763. Complete the table below. Measure of the angle formed by the initial ray and the terminal ray passing through the given point in radians. Okay, so notice that each one just increases by pi over 18. 1 pi over 18, 2 pi over 18, so this one will be 3 pi over 18. Alright, that one's done. Ordered pair describing the point's location. All of these are just cosine of the angle, comma, sine of the angle. So we're just missing this one. Cosine of pi over 3 is 1/2, and the sine of pi over 3 is square root of 3 over 2, which is 0.5, and 0.866. By the way, we could have simplified this to pi over 6. Notice that these are reversed, 0.866.5 and 0.866. That's not a coincidence. Let's see. The slope of the terminal ray passing through the given point M. These are all just the change in y over change in x, are just sine of theta divided by cosine of theta. So sine of 0 over cosine of 0, 0 over 1 is 0, and then we can just calculate the rest of these. Something interesting happens with the last one. If we try to do sine over cosine, that would be 1 over 0, which is not defined. An interesting question is, what happens to this ratio as theta approaches 0? Well, as theta approaches 0, the slope approaches infinity. And we could see that on our graph here. The closer that we get to point J, the steeper this graph gets, and it's going to become infinitely steep. So what do I mean? I mean, well, here's a point. It's not, a line. It's not very steep, but the closer we get, the steeper the line gets. So we're approaching infinity. Notice these are getting progressively larger. Oh, and I said that wrong. This is as theta approaches pi over 2. Okay, because that's the next question, actually. What happens to the slope as the terminal rate of theta approaches pi over 2? As theta approaches pi over 2, the slope, which is sine theta over cosine theta, approaches infinity. So essentially, the slope increases without bound, and we have a vertical asymptote at x equals pi over 2. Not x, theta. So if we graphed the slope on the y-axis and the theta on the x-axis, we'd have a vertical asymptote at pi over 2. For what angle measure theta between theta and theta equal 2 will the slope of the terminal ray be 1? I think there is a typo in this question. This should be theta equals 0. So that's what we've been looking at, between 0 and pi over 2. When will the slope be 1? We can look at our little table here and see that looks like the slope will be 1 in between these 2 points, in between the angles 2 pi over 9 and 5 pi over 18, which if we go back to our circle, see 1 pi over 18, 2 pi over 18, 3 pi over 18, 4 pi over 18, 5 pi over 18, probably in the middle, like right here. The slope of this line will be 1. And notice that it's right smack dab in the middle. This is actually theta equals pi over 4. Now let's think about how the slope of the terminal ray and the angle measure covary in the second quadrant. That is, when theta is between pi over 2 and pi. When theta is between pi over 2 and pi, is the slope of the terminal ray positive or negative? Well, looks negative to me. Let's see, the value of y decreases as the value of x increases. That's one way that I know, like any line over here will have a negative slope. We could also say that the change in y will always be negative. And then the book's answer is the terminal ray falls from left to right, so it's negative. As theta increases from pi over 2 to pi, how does the slope of the terminal ray vary? Well, what's going to happen here is our slopes are going to decrease. Well, I have to be careful because they're all negative. As we go to pi, like here, the slope is actually 0. But up here, we have a very negative slope. So the slope is actually increasing. The slope of the terminal ray is increasing. It is becoming less negative and approaches 0. For what angle measure theta between theta equals pi over 2 and theta equals pi will the slope of the terminal ray be -1? We're going to have -1 right in the middle, somewhere, right in the middle. And that's let's see, a quarter of an angle, a quarter of the top half of the circumference away. So pi over 4, 2 pi over 4, 3 pi over 4 is that angle. Now let's think about how the slope of the terminal ray and the angle measure covary in the third quadrant. When theta is between pi and 3 pi over 2, what is the is the slope of the terminal ray positive or negative? Justify your answer. Here in the third quadrant, our rays will look like this. And these have a positive slope. As theta increases from theta equals pi to 3 pi over 2, how does the slope of the terminal ray vary? So notice what happens if I start here, a pretty small slope, and then as I move to 3 pi over 2, the slopes of these lines gets larger and larger till down here where actually our slope is like increasing without bound the closer we get to 3 pi over 2. Now let's think about how the slope of the terminal ray and the angle measure covary in the fourth quadrant. When theta is between 3 pi over 2 and 2 pi, is the slope of the terminal ray positive or negative? Justify your answer. So, in this fourth quadrant, you can take a look at the lines where the terminal rays are decreasing to the right as x increases, so these all have negative slopes. And notice that as we move from 3 pi over 2 to 2 pi, they are negative slopes, but they become less and less negative, approaching 0. So they're increasing. For what angle measures theta between theta equals pi and 2 pi would the slope of the terminal ray be 1? So the rise and run have to be equal, which would be right here at this point. We go up the same distance as we go over. And that angle is 5 pi over 4. You could find the angle in degrees, that might be easier, and then think about like converting it to radians, or just count, let's see, there would be, I can't find my clicker, 1 pi over 4 here, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4. How about negative 1? Negative 1 would just be the opposite side in the fourth quadrant right here. And that angle would be 7 pi over 4. When would it be greater than 1? Let's see. During this region right here, the slope would be greater than 1. After it moved across that line, it would be negative, and if it was below that line, it would not be greater than 1. So this is an interval from 5 pi over 4 to 3 pi over 2. For all those angle measures in between, we'd have our slope greater than 1, and less than negative 1 would be here. Those angles would be more negative. Three pi over 2 to 7 pi over 4. The function you've been working with is called the tangent function and is abbreviated as f of theta equals tangent theta. The tangent function is a function that takes as its input an angle measure from the 3 o'clock position and outputs the slope of the terminal ray of the angle. So sine of theta over cosine theta, that's the tangent function, the slope of the terminal rays. Without using a calculator, to determine if each of the following statements is true or false, justify your answer by drawing a diagram or with a written explanation. Tangent of 2 pi over 3. Well, tangent of 2 pi over 3. Let's just draw a picture of a circle. It's almost a circle. 2 pi over 3. So if this is our initial angle at the or this is our initial side at the 3 o'clock position, then 2 pi over 3 would be about right here, and that slope is less than 0, so that one's true. Pi over 5, that's going to be in the first quadrant, and so that one is positive slope. The tangent's not less than 0. That one's false. Let's see, tangent of 4 pi over 3, that's a little bit more than pi, so our terminal ray will be over here, which is positive, so that's true. Tangent of 7 pi over 8, that's a little bit less than pi, and it would be about right here, and that has a negative slope, so that one is false. Use a calculator to evaluate each of the following, then interpret the meaning of your answer. Tangent of 75 is about 3.7321, and so what does that mean? The slope of the line that hold on, let's say the slope of the ray, or the terminal ray, whose angle is 75 degrees, is 3.7321. Let's see, this one is about 0.4816. You might have to change your calculator to different modes. For the top one, you have to be in degree mode, and the second one in radian mode. The slope of the terminal ray, whose angle is pi over 7, is 0.4816. Here we need radian mode again. Type this one in your calculator. You should get about negative 3.077. So the slope of the terminal ray, whose angle is 3 pi over 5, is negative 3.077. Sketch a graph of the slope of the terminal ray versus the angle measure. So that means that our angle measure theta is this axis, and the terminal ray, the slope of the terminal ray is this axis. As the angle measure varies from 0 radians to 2 pi radians. So let's just put 2 pi right here. So here's pi in the middle. Pi over 2 would be about right here. And 3 pi over 2 about right here. Remember that the slope increased without bound. So we sort of started off here, we got to a slope of 1, and then we just keep increasing. It was positive there. Then after that, we have extremely high negative values, and then we get to pi, which is the slope of 0, and then we again increase without bound, and then we're very highly negative again, and then we increase up to 0. So we've identified two vertical asymptotes here at pi over 2 and 3 pi over 2. And in general, the graph of the tangent function looks like this. You might want to graph it on your calculator. It's a pretty crazy looking graph, which is just the graph of the slopes. What is the period of the tangent function? You see it starts to repeat after only pi units. So the period is pi. What are the vertical asymptotes located, and why do these occur for these values of theta? Well, the vertical asymptotes are at theta equals pi over 2 and theta equals 3 pi over 2. There's actually an infinite number of these, but these are just the ones we identified on our graph. And the slope increases or decreases without bound as we approach these points from the left or the right. Use the following diagrams to help you explain why the slopes of the terminal ray are the same whenever the angle measure differs by pi radians. Well, this looks kind of fun. So here's theta. Right here you can see the slope of the terminal ray. Then if you go theta and you add pi radians, you're just going to be 180 degrees away, and you have the same line, the same slope. Or we could go theta this direction, but then subtract pi, and we again have the same slope. So are we supposed to do something here? In exercise 1, you are asked to calculate the slope of the terminal ray of the angle when you knew that the ray began at the origin and passed through a point on the circle. For example, if the terminal ray passed through the point 0.1736.9848, then the slope was 5.673. Suppose you know that an angle measures theta radians using a circle of radius 5. How can you find the point xy on the circle that the terminal ray passes through? Well, if we have a circle like this point xy will be equal to 5 cosine theta, 5 sine theta. Using your answer to part A, complete the following statement by writing tan theta in terms of cosine theta and sine theta. In other words, when we know the value of cosine theta and sine theta, how can we find the value of tangent theta? Well, tangent theta is simply the change in y over the change in x, because it's the slope of the line. So it'll be 5 sine theta over 5 cosine theta, which is simply sine of theta over cosine theta. In earlier investigations, we determined that we can find a point xy on the circle using x equals r cosine theta and y equals r sine theta, instead of just x equals r cosine theta and y equals r sine theta, where r is the radius of the circle. If the radius of a circle is r, is the slope of the terminal side m equal r tangent theta or m equal tangent theta? So the answer is tangent theta. Notice that the radius r here canceled out, the 5's just canceled out when you calculate the slope. So you could note that no matter which you pick, if you find the slope, it'll just be r sine theta over r cosine theta, which will just be sine theta over cosine theta, which is tangent to theta.